This is our AI project titled Smart Sage, an intelligent assistant designed to make learning, researching, and productivity smarter and more interactive using advanced AI technologies. In today's world, we deal with massive amounts of information, from textbooks and research papers to web content. It is difficult to extract meaningful insights, take proper notes, or retain information efficiently. Traditional tools often just give us a list of links, not actual answers. That is where Smart Sage comes in. Our system is built around a powerful AI framework called Retrieval Augmented Generation or RAG. This diagram shows how RAG works. First, your documents like PDF or Word files are processed by an embedding model, which converts the content into numerical representation called embeddings. These are stored in a vector database. When you ask a question, your query is also embedded and matched against this database to retrieve the most relevant chunks of information. That context is then combined with your query and sent to a language model like Gemini, which generates a well-structured context-aware response. So instead of guessing it, answers based on what it actually found in your data. Along with this smart answering system, Smart Sage offers many features. It allows us to upload PDF, Word files, PowerPoint files, and multiple images to extract data from. We can interact via text or the voice feature. It allows us to enable web search. If no answer is found in document, it auto-fetches data from internet and gives reference link. We can generate nodes, make flashcards, and even memory anchors. We have also introduced a Pomodoro timer with webcam-based fatigue detection, which detect yawns and eye closure. We can get personalized task tracking, motivational quotes, and productivity insight. It also allows us to export our chats in multiple formats and export our notes as PDFs. The front end of this project is built using HTML, CSS, and JavaScript and is powered by a Flask backend. We used Pinecone for semantic retrieval and Gemini APIs for generating high-quality responses. Computer vision is used for real-time fatigue detection. All the features of the project would be explained in the following sections of the video.
We have used three main track techniques in our project to generate better answer and tackle complex and ambiguous prompts. The first one is multi-query. Multi-query expands a single user query into multiple diverse variations using paraphrasing or prompting techniques. So it will take a single user query and will generate three different rephrased versions using large language model. The second technique that we have used is decomposition. It breaks down a complex query into simpler sub-questions, and each sub-question is handled independently to retrieve more focused information. And the final answer is constructed by combining these responses. So here you can see that it is taking the user's prompt and is breaking complex questions into 2 to 3 simpler standalone sub-questions. And this function is basically the third function. It's a helper function. It generates a step-by-step plan to answer the given questions and provide reasoning steps to guide information retrieval, especially for complex queries. The third technique is RAG fusion. RAG fusion combines multiple lists of retrieved documents. The list of retrieved documents, like we are retrieving documents using multi-query and decomposition method. And after the retrieval, this particular technique will score them based on how highly they appear in each list, right? So these functions will basically enhance the RAG pipeline by generating varied and focused queries to produce more accurate and complete answers. So let's have a look into the main function, how they are working. So when the user enters the question, the prompt, the code first passes into these three functions, right? And these functions use the Gemini large language model to create rephrased versions of questions and reasoning steps based on the prompts. And each of these queries is then passed into the vector store retriever to fetch relevant documents. All the retrieved document lists are combined using reciprocal rank function, which is the RAG technique that we have used. and it will prioritize documents that appear frequently across users, right? So the doc documents are merged into a single context string, and this context string, along with the original question, is then passed to a LangChain prompt template. This is the prompt template, right? The context, it will pass into the LangChain prompt template, and it's sent to the Gemini large language model to generate an answer strictly based on the retrieved documents, right? So this was the implementation, and let's see how it works. So I have uploaded a file. The file was related to operating system. I've processed it, and then I asked this question. I did this because it takes time now, that's why. So the documents I had uploaded, there were different sections of synchronization problems. In a section, the dining philosopher problems were listed. In another section, producer consumer problems were listed. So it has retrieved correctly, I guess, and the RAG techniques are working fine, right? So in the later section of our video, you will see the other features that we have implemented in our RAG project. Thank you.
Hey everyone, so I'm going to show you right now our study monitoring feature in our project. So let me just demonstrate all its feature. So first we've got the core feature, our AI focus monitoring. So when I start the system which I already have, what this you see this webcam open, and what this does is that it tracks your eyes and it tracks your mouth. For mouth, you like, what if you're yawning, like you're not focusing much, and what if you just closed your eyes and you've been sleeping? So it's just like will send an alert if you've been sleeping or you're too tired. So I'll just demonstrate it for you. So you see, it's just tracking my focus, if I'm focusing on studying or not. So if I start to doze off, you'll hear the alert sound. It's keeping me focused. And then we've got this timer. So basically, when I click on the start button, this whole webcam will start, and then my Pomodoro timer will start. So Pomodoro is actually a technique which helps us studying. So what it does is that we study for 25 minutes, and then we take a break for 5 minutes. So it's tracking the time that I've been studying my session, my first session, and then after the 25 minutes, it will suggest me to take a break. And then we've got this task management here. So what it does is that I can like choose the category of my task, or if it's problem solving, like maybe numerical assignment, numerical method assignment, and then I can add a task here. So you can see the task on the right side here. I can just tick them off, and it will show me in what session I completed this task. Like for example, if I tick this off, it shows that you completed this task in session 1. And then if I tick this off, it's obviously I'm still in session one, so it will say I completed this task in session 1. And when I complete all my tasks, it shows me a message that I've completed all my tasks. A smart break suggestion. You see this motivation here. So throughout this session, you'll see these motivational messages. They are context aware. So when you're doing like a reading task, you'll see motivations for reading. And also when you're too tired, when you're yawning and you're just closing your eyes, a lot of the time, many times you'll see motivation here. And then if maybe you're too tired that you've like closed your eye for the 5 times, then this will auto suggest you to take a break right now because you're too tired to continue. So these motivations are personalized based on your focus and based on your task. Now that you've seen the features, I'll walk you through this code implementation. Here we are importing the important libraries. You see this media pipe library here. This is used for the facial mesh. So basically this helps in tracking my mouth and eyes. And so we have this class which is basically handling everything. And then so this sets up all the variables needed for the monitoring, tracking drowsiness, tasks, and motivational quotes, and then like alert sounds and camera and drowsiness patterns and tasks, everything.
So you see this distance, I'm calculating here the distance between the 2 points, so for facial landmark. And then if I go here, I see this get ear, which is ear is basically EAR, which is eye aspect ratio, which helps in calculating the eye aspect ratio, which detects if your eyes are closed, which is also a sign of drowsiness, if I'm sleeping or not. And then here it will play the alert sound if my eyes are closed. And then I have this task specific quotation, like whatever I'm tasked and I'm doing, like if I'm reading, I'll get the specific task. Here this is break suggestion. So if I'm too tired, you see, if I've been yawning for like maybe 3 times, it will say high drowsiness detected. And then if it's like 2 times or more, it will say that you're showing signs of tiredness. And also it will suggest me a break if I have been studying for 25 minutes, which is the Pomodoro session. And then I've got some start monitoring and stop monitoring, which will call the OpenCV library, which will open the webcam and track me. And then I've got so here we are just generating the frames. Basically what's happening here is that it continuously reads the frame from the webcam, detects the facial marks for eyes and mouth, calculate the EAR and MAR. MAR is basically for my mouth, and then EAR is for my eyes. And then if drowsiness is detected, shows a warning, plays the alert, and then updates the motivational codes. That's what's happening here. And then you see here we've got task management here. I'll set it lets me set my current task and update its completion status if I've completed it or not. So this here is basically what it's doing is, this is the Flask backend for task management. When you edit task, it creates a dictionary, and then it has the task name, type, completion status, and even tracks drowsiness events during the specific event. Like in that specific task, I was too tired or something, then it will just track. This helps us understand which type of task might be more challenging. And then we've got this break here, which this basically starting the break time, and this is the ending break time. Here we are like resetting all the drowsiness patterns after the break. Like after every session, my drowsiness patterns are changed. So what if in my break I became like very active?
I'll be talking about the features that I've added in this project. The first one is this flashcard game. It's a very unique but fun way to study, since people do tend to do better in a competitive and pressurized environment. I've also added a challenge mode in it, which runs on a timer. So it's like a game against time when you have to answer this question as quick as possible. It's not a quiz, it's more of a flashcard kind of a thing. You have a question, you answer it to yourself, and you check it if you knew that or if you didn't. It also shows you the answer if you didn't know it, and if you knew the answer, you'll check on it. Is the goal for the flashcards. I've used Gemini Pro Flash 1.5 model to generate the questions and the answers. Here in the get remaining time, it keeps the track of the time remaining. And this is the challenge mode, where you turn it on to get the timer. It keeps track of the flashcards that you answered correct and the ones that you've answered wrong. It keeps track for score and the total, and at the end of the game, it will display your total score. Yeah, this is the prompt that I've given it. It generates flashcards based on the document that we've uploaded. I had already uploaded my document, so it was generating based on that. Let's go back to the UI. It is. Here's the question, here's the answer. I can simply click on I didn't know, and it will not anything give the next flash. That's it for this feature. This is the next feature that I've implemented. It's a memory anchor. You give it a concept and it'll generate a summary, a mnemonic, and an example for you. It's so great for last minute studying prep. So you could just give it a concept and it'll directly generate all these things for you. And these things such as mnemonics make it very easy for you to memorize the stuff or to remember stuff such that, like, right now I've given it Q and I've given me the summary of Q, the mnemonic for Q, and an example for you that will help me visualize that. I could just give it something from some other field, like let me give it like something like red blood cells. Then it's that code till it generates. So here it is. I've given it a prompt. It uses Gemini to get a response from that prompt and convert it into JSON format, and I've displayed it in the UI using JavaScript and the HTML, the regulars. So this is the prompt that I've given, and it also saves anchor in that file, so you can revisit it later if you want to. Let's see if you have that loaded. See, RBCs. So another feature that I wanted to talk about was this notes feature. You know how whenever we use AI sites or some external sites to generate notes for us, we go to Microsoft Word or Google Docs to compile all those separate snippets and pieces of notes that we've gathered. So you can now do it all in one website. See, isn't that amazing? You can do it all in one website. You get information about your documents from here, and then you compile them in the same app. You don't have to use several apps and all that hassle. You don't have to do it anymore. It does all the basic formatting features, and you can also download it and save it for the next session. Let me open the code as well. Yeah, here it is the button, and I've used memory invites to change it to a downloadable form since the PDF was not directly accessible. Here it is. So this function basically makes the downloadable file for exporting the notes.
The web app includes speech-to-text functionality, which allows user to speak into their microphone and have their speech automatically converted into text input in the chat. When the user clicks to the microphone icon, the input button, the browser starts listening using the built-in speech recognition provided by Chrome. While listening, the app shows a listening indicator and changes to stop button. Once the user finishes speaking, the browser converts the audio to text using internal speech recognition engine. The recognized text is automatically filled into the chat input box. If the detected text is not empty, the app automatically submits it to the chatbot, just like a regular text input. If there's any error during recognition or if the user cancels it, the UI resets to the default microphone icon. Now this allows a hand-free interaction with the chatbot, making it more convenient for users who prefer speaking rather than type. Now let's see a demonstration of voice input. First we have to upload a PDF file, process the file, let's give a voice command, explain agents. The bot text reply also converts it into speech. This adds an audio output feature, making it more interactive for the and useful for users who prefer listening.
Page facing up document answer. An agent. Asterisk is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Asterisk has a